Hello and welcome back. In this video we're talking about the geometry of the cross product. What geometric properties does it have? This is going to turn out to be very important for us. So just like the dot product had certain geometric properties, so does the cross product. And it gives us a really sort of intuitive way to kind of feel the cross product. So the idea is, if I want to take the cross product of u and v and figure out u cross v, so I'm just going to draw two vectors in the plane here. Let's say these are my two vectors, u and v. The cross product, since these are both in the plane that we're looking at, the computer screen, the cross product, so first off, test your knowledge of the cross product. Which way will u cross v go? Which way will the torque go? Will it go in or out? So remember, point your fingers along u and curl them in the direction of v. So v is sort of going down from u. You can, if you want, you can sort of move this v up, or rather move the u. No, so the u is the lever arm. So I'll move this v up. Think of v as like the force. So I'll just move v up. It's parallel to v, same magnitude, everything. I'm just sort of moving it. So there's v again. And imagine u as the wrench and v as the force I'm applying to that wrench. So point your fingers in the direction of u, curl them downward in the direction of v. Your thumb should point in, so the torque u cross v here would go inward. In this example, u cross v goes into the screen. Okay, so that's cool. What we're getting at here, though, is we want to get at the geometry of the cross product. So I've moved v, I've put it up here. I'm also going to do the same thing for u. I'm just going to move it over here. And I just want to look at this a second. So remember, the magnitude of u cross v was magnitude u times magnitude v times sine of the angle between them. Remember, this is how we defined the cross product. Here's my angle between them. So this parallelogram that's formed, so imagine all this stuff in here, this parallelogram that's formed has a height to it. If I drop a perpendicular from u, something perpendicular to v, so a projection, it has this height to it. What's that height? Well, that height is u sine theta. This height is magnitude u times sine theta. And then the length of this parallelogram is the magnitude of v. So that is, this parallelogram has area, really cool, magnitude u times magnitude v times sine of theta. And that is exactly the magnitude of u cross v, as we saw up here by our definition. So another way to think of the cross product, or rather just the magnitude of the cross product, because remember it also comes with a direction, but the magnitude of the cross product is the area of this parallelogram. So this, again, this is a nice way to feel the cross product, because now I can ask a question like, well, what if u and v are parallel? What if they're going in the same direction as each other? So let me maybe get some more room. So what if my u vector goes here? And what if my v vector is parallel to that? Maybe in the opposite direction even, but still parallel. Well, these do not form a parallelogram. Since they're parallel to each other, it has no height. And so u cross v, the magnitude of u cross v, would just be 0. The area is 0. So we'd get the 0 vector out of this. That would be the same as if I went opposite or towards it. Again, think about torque. If I apply a force parallel to the lever arm, to the wrench, I'm not going to have any twisting effect. So two sort of ways to feel this. And then this area thing is a more specific kind of a feeling, a little bit more analytic of a feeling, right? It's the area of this parallelogram. So you can imagine if u and v are perpendicular to each other, if they're exactly perpendicular to each other, what happens then? So there's my u, and there's my v, or maybe backwards. What happens then? Well, if I copy these vectors down, if I form this parallelogram, I get exactly a square. And that tracks length, area of this square, of this rectangle rather, is length times width. So this is magnitude v. This would be magnitude u. And if they're parallel, or if they're perpendicular, so that means this is a right angle, this is 90 degrees, or pi over 2, we get a square, and in this case, u cross v would be magnitude u times magnitude v. In this case, so if u and v are perpendicular, that's a little symbol that means perpendicular, then magnitude of u cross v, that the area is a rectangle, and so it's just length times width. And that tracks because sine of theta, sine of 90 degrees is 1, and so that sine theta term sort of just disappears as a factor of 1, and we're just left with magnitude v. If they're parallel to each other, then theta is either 0 or pi. Sine of 0 or pi is 0, and so again we get 0 here. So let me just write that here. If parallel, u and v that is, then u magnitude of the cross product is 0. And in fact, we can say not just the magnitude, but the vector that comes out of this would be the 0 vector. U cross v is the 0 vector. Here we'd have to do the right-hand rule to determine the direction of u cross v. All right, I do want to jump to a example in the e-textbook real quick. I'll jump to there real quickly. You can visualize this. You can play around with this idea inside of your e-text. This is a nice way, again, to get the feel of it. So here, u and v are perpendicular to each other, so they form a rectangle. Again, curl your fingers in the direction, point your fingers in the direction of u, curl them towards v, and you will see that your thumb points up the direction of u cross v. And then you can play around with this for a while. Let's move v around. Maybe let's make it, like that. Maybe let's have it point over here. Notice that u cross v just flipped when I did that, because now v is sort of on the other side of u. If I point my fingers along u, curl them in the direction of v, you'll see the thumb is pointing downward. That changed the direction of u cross v. It also made this parallelogram, since their angle between them is pretty small, it made this parallelogram, the area, pretty small, and that's why u cross v is just a small little vector here pointing directly down. What if I say moved the y component of v, what if I made it -1, had it point more this way? Now the parallelogram has more area. It's still going in the same direction, but it's stronger. All right, well, what if I put, let's say a z, let me maybe move this back to, let's go 1 here, I'll have it pointing that way. What if I put a z component to this? So we've only really looked at, in our examples, if I was applying a force in the plane that the wrench was in. So I can also add a z component to v, and what's going to happen then if I do this? Oh, it's not really, there we go. So now the plane containing u and v has changed. It's no longer the xy plane. It's now sort of pointing up like this, and you'll see that the cross product is now pointing a bit to the negative y direction. It's always going to be perpendicular to the plane containing u and v. So let's maybe change, that's not a good look. Let's maybe change this. Again, I'm going to switch this to a -1. We'll go on the other side. What's going to happen? We should see u cross v pointing downward and in the positive y direction. Let's see if I can get it to do that. Is that quite what I was expecting? No, it wasn't. It's pointing downward, but still in the negative y direction. And that was because of this flip that happened. So it's good when you can do an experiment and see if what you expect to happen happens or not. And then you can ask yourself, well, why, if it didn't happen the way you thought it would, you can ask yourself, well, why? And you can always go back to this right-hand rule. Again, point your fingers in the direction of u, curl them towards v. You'll see your thumb is pointing sort of downward like this. So this is a nice tool to play around with, and again, the idea here is to get a better feel of what the cross product is. Remember that its magnitude is the area of this parallelogram, and direction is determined by the right-hand rule. All right, that's it for this video. I'll see you next time. We'll talk about the algebraic properties of the cross product. I'll see you there.